So in this session, we are going to demonstrate model-based testing. And we will demonstrate how to create test cases for the system to do the testing of system architecture or the design. And we will demonstrate the behavior part testing. So here in the model, we have the final solution for complete model-based testing. And it is done on a publicly available sample, which is vehicle climate control system. You can find this from sample folder. And here we see the behavior of climate control system cooling subsystem. And here we see this behavior. It starts in off state, then on turning on is switched to on state, and then it starts initializing. And we are going to test initialization if it is if compressor here in initialization, if compressor starts in 20 seconds, if we receive compressor system started signal, the system will go to operational state. If compressor is not initialized in 20 seconds, system will switch to diagnosing mode or state. And we will check this behavior. We will check initialization and that system reacts correctly to the initialization time. We will check basically two requirements. So those requirements we can see here. Initialization of compressor. Compressor shall start within 20 seconds from start of the cooling system. And another one, diagnosing. If compressor does not initialize within 20 seconds, cooling system shall switch to a diagnosing mode. We see that those two test cases will test this behavior. And here we have those two test cases. They were recorded in a sequence diagram, which is representing the test case. So first one sending turn on signals from off to on, and then checking on state and checking diagnosing state. Now with the turn off, now we switch to turn off. And then we check that we send the turn on signal, and we send the compressor system started, and we check that the switch responds by switching to operating state. This compressor system started signal could come from the compressor, but we want to check this isolated component with its behavior without checking whole system. So this is the isolated capability of the system. And when we run the execution, we record the test cases into the instance table with the results. So now we will run this execution, and we will see that both test cases passed, right? So the test cases actually test the system behavior and as designed, and they passed, right? So now if I will put here different time, for example, it will fail if I will say that I will wait 25 seconds to check for the compressor initialization, and if compressor is not started in 25 seconds, then only will switch to diagnosing. But because test waits only 21 seconds to check this, so this test will fail because it will check and this switch is not yet done, right? So if I will run this test again, I should see the different behavior. I should see that it actually failed. So let's run this test. And we see that this test failed, right? So this test failed. And again, we are testing the system, cooling system. This is the system and the test. And here we see the orchestration of the test cases. So we can run those test cases, all of them in the design sequence. And also we could schedule that running regularly as the automated solution. One more thing, what we could do, we could track the execution trace in order to be able to find out visually what is the failure, what was the response of the system, and we can track that with the sequence diagram generator. So now if I will run the tests, I see that this is recorded into the sequence diagram. So I could follow this trace of the execution and find out the system response. So I would know, what's the failure caused by. And I see that everything gets recorded into the, here we see that everything gets recorded into the results package. All those execution instances and the sequence diagrams. Now we will open an empty project with the cooling system design, and again, this is out of the box sample. We see here this cooling system has the structure and cooling system structure, and now we will test this cooling system design, right? So we will go back here. This is the cooling system state machine. So to test it, we will create the, first of all, to set up the test cases, we will create the testing package here. Inside of the testing package, I create the results package. And as always, I will start with the block definition diagram to create the context for testing or analysis. So we will do specific type of testing for the two requirements: initialization of compressor and diagnosis. That this will switch to the diagnosis if the initialization is not done in 20 seconds, and that initialization should be successful in 20 seconds. So we will test those two requirements. So we can create a test context, testing initialization, and we will make our system as a part of this context. So this is very convenient because now we will not affect the system, but also we will see every part of the system, including that behavior. We could execute this one block, and the system will be executed together. So next step is to create activity diagram to orchestrate the test cases. In order to not run all of them or to run them in specific sequence, we can create this activity diagram. For now, we will leave it empty. And we will start by creating test cases. So now we will create test cases. First of all, we will create first test case. We will use sequence diagram because it is quite convenient. Based on the SysML standard, we can represent test cases in any behavior. Sequence diagram is convenient to run the test case, which sends the signals and checks that state or property is the right value. After the signal is sent and system responds to that signal. So now I will record this behavior here in the sequence diagram. So first of all, I will send a message here, and this will be turn on. I use existing signals, and now I will check that system is in on and diagnosing states after that. So okay. Let's put the state invariant here. So system is in on, and system will be in diagnosing states. And I can hide those activations. I don't need them, right? So hide activations. Okay. Now I can put durations, and durations are very important because this is the test case. So this test case runs as fast as there is any time specified. Without time specified between those send signal messages and checking the state, this is immediate, right? So we need to give the system some time to respond to the send signal. So we send turn on, system switch to on, starts initializing, it waits for 20 seconds, right? And then it switches to diagnosing state. So we need to check it after the 21 second or 20 seconds plus something, right? So we can check on 21 second, should be okay. And now system will switch to on state and diagnosing state. So we could give some kind of delay here just to be safe. Maybe even without delay it will be okay, right? So depends on what kind of situation is here in the system behavior model. But with some delay, it was always safer. Now that's it. So we pretty much could could apply the test stereotype here in the test case, and this this sequence diagram will become test case. Test case stereotype. And the only difference what we got when we apply the stereotype, we got this verdict. This verdict will be producing value. This parameter will produce the value. On the end of the sequence diagram execution, it will be pass or fail. If passed, this constraint, those all constraints are passed, it will produce pass verdict. If any of constraints in this sequence diagram, means like property check or state check, will fail, it will produce fail verdict. Now let's rename this testing initialization fail. And now we will create another sequence diagram to test initialization pass. Okay, testing initialization. Okay, so this will be if it's initialized. Okay. And here will be again. Now we will start with the send signal, but this signal will not be turned on. First of all, we will turn off, because after last test, system still stays in the same behavior unless we will end this whole behavior. But we could, continue running. We will hide activations here. And now here I can say that, okay, turn off. Now we will turn on. Now checking the sending the compressor is okay signal. Compressor system started. Again, this could be sent by the compressor component, but we are testing isolated component behavior on this, so that's why we need to send something which it is listening for. And then, oh, that's it. So now we can check that system is in on state, and it is in the operating state. And we will put some delays. Those delays are just to be safe that the system has the time to respond. It will be very minimum delays. It will be 0.1 second. Should be enough. In any case, this time doesn't affect the execution time of the state of the test and system response to the test, because when we will run those tests, we will run them in the relative time. So system can, run in the execution of the days in seconds, and this really is not affecting the actual execution of the test. So we have this test. This should run okay, and then check that system is in operating state at the end. Again, we will apply test case stereotype. Test case stereotype. And now we will want to store those both test cases results to the properties as we saw in the final solution. So we will create those properties. Create a value property. Initialization. Okay. And copy. Level 1 initialization not okay. And the type will be verdict kind. This is because the parameter type is like that. So if we want to store the value, we can use the same. Okay, I can rename this test case also to initialization not okay. Not okay. Okay. Now in that activity diagram, I will orchestrate the testing. So okay, not okay, and store results. Results will be stored with help of this opaque action. So this will take this OK property and will assign the value of first test. Here we have this value coming here, and this is coming as the V. Now we'll take the second result and we'll update the another property value. So this will be a initialization not OK. V, and we will set up here. So both will run. This will start. The next one, results will be updated here. We can run that in this sequence. Could be, different sequences, different test sequences based on different needs, right? Now we need to set up the timing. Without that, computer clock will be used, and this is not very good because it has some delays here, animation delays, and they will not be followed by the test delays. So we need to set up the simulation config, and here we will have config to test initialization, and then this is the testing, and the results will be stored into the results package. So we can drag the results here package, and as a result of that, we will get instance of this block into results package every time we run, and with the timestamp. In the timing here, it's very important we will set up the timing properties, and those timing properties are good for any type of execution, like start time 0, step delay doesn't matter, step size 1. So every time something happens in execution, the time is used, so we know that this is 1. And then unit seconds. We could put here days or something, depends on what kind of system time unit is. That's it. So now we will have exactly time based on the duration of the property constraints. Step delay, that's it. Step delay we could specify if we want to see animation, with some delay visually. Now we could run this behavior and we will get the results. And before that, actually in the results package, I will create an instance table, and we'll set that that element instance I will going to see here, test initialization, and from that package. Here we go. Now we can drag it here in order to see. It, can take it and drop it here. Now, every time we run, we will see those two test cases with the pass-fail results. Let's try. Let's run and see. And I'm running still with animation to be sure that actually test cases are running. Okay, first passed, second failed. Let's see what happened. So I go here back to the testing. This is initialization okay, this is failed. I think the sequence was wrong because first of all I turned off, but it was turning off on the second. I need to turn off on the second iteration, right? So I will go here, remove, and now I will change the sequence of execution. So I will move this below. This doesn't matter what is the sequence. You can make that sequence different, but if you want to react to the previous results and then restore the system to initial state, then it is important to do so. You can't really run the system again without doing that that setup, unless you will run by finishing the execution and starting the execution again. Now let's see that it runs correctly or not. So I will run this test case. First test failed solution, failed case, and then second test passed case. So we see that execution passed and the timestamp is exactly as in my clock. So now let's try to fail the execution, and let's change the system design to that it will wait for 25 seconds and the execution should fail in this case. because we will wait only 21 seconds. And we see that it's failed, right? So that's the final solution. And actually, we also can create this system execution trace with the sequence diagram recording. So record trace, and we can set it here. And we can also say that show timestamps. By default, it doesn't show timestamps. Okay, so now, oh, and also the way it will be set as owner, the way in which package it will store results as the sequence diagrams. So we can store them in the testing package, in the results package also. So now if I will run this, I will see recorded execution in the sequence diagram. Again, it failed, right? Because I set up like that. And I see that execution was done, trace was recorded and put into results package. Here we have this one. If I will fix the system again, here, to 20 or something less, it will work without any problems. Again, we have this sequence diagram recorded as the execution trace. It's not important, not must, right? But also because we can, rerun any instance. We can take any instance with the situation when the test failed, and we can right-click and say simulation run, and then we will see that instance executed and see what was the situation, right? So with the test case. So this is a complete solution in the model, and we can use the system, as the read-only package in the model, and then we have those tests in the system based on the recent updates in the model. Also, we could schedule the tests. This is still not public solution to schedule the tests and run magic draw in the headless mode, but this is coming to the public solution in the nearest future. Then we will be able to run the test config, simulation config from the command line, and in the morning check results file with the test result.